Okay, it says the gravitational force F between an object and the Earth is inversely proportional to the square of the distance. All right, so let's highlight our keywords there. Gravitational force, which gravitational is just a adjective. It describes the force. So we have a force that is inversely proportional to the square of the distance. My force is inversely proportional to the square of the distance. So do you remember the difference between a direct variation and an inverse variation? Yes. Okay. Right, so this is an inverse, so I'm going to divide. So I start off with F for force, and then I always put an equal sign, and then I put a K. Every problem always has the equal sign and then the K. All right, now, it says inversely, so I divide. What do I want to divide by?
Distance squared.
The distance squared. All right, well, let's be careful. We may have to draw a little bit of a picture here. The distance from what? The distance from the object and the center of the Earth. So in this case, we're talking about an astronaut. So I'm going to kind of draw a picture here of what's going on. Here's this circle is my Earth. So you're going to draw a circle for your Earth. I didn't draw it. I just grabbed the circle tool. And it says, what's the radius of the Earth? Does it tell me that?
Yes, 4,000.
It's approximately 4,000 miles. Okay? So they've rounded to the nearest 1,000 there. It's between 3,500 and 4,000 actually. But anyway, they rounded it to the nearest 1,000, so that's my radius for my Earth. Right, Corbin? So now, my astronaut on the Earth, so when the astronaut is on the Earth, he weighs how much?
200 pounds.
200 pounds when he's on the Earth. But then when he's in outer space, we're supposed to figure out what he would weigh out there. Why do you weigh different in outer space? Because eventually, when you get outside the atmosphere, you're weightless and you'll float around in a whatever item you're traveling in, right? So, does it tell me how far the astronaut is from the surface of the Earth? 3,750? So this distance is 3,750. So the distance from the center of the Earth to the edge of the Earth is 4,000, but the distance from the center to where the astronaut is in outer space would be these two numbers added together. You agree?
Yes.
Okay, so I'm going to start off with, I know how much he weighs on the Earth, right? So I'm going to replace this force with what he weighs on the Earth, and the distance would be 4,000 because that's how far he is from the center if he's at the edge. If he's on the surface, he's 4,000 miles from the center. And it says my distance is how far the object is from the center of the Earth. All right, so oh no. It's not letting me move my object. Okay, that's all right. I'll just rewrite that. Okay, so force is equal to K divided by D squared, and force represents the weight. So my weight is 200 pounds on the surface of the Earth, and that is 4,000 miles from the center, right? So I have a 4,000 squared. How am I going to solve for K?
You're going to multiply it by 4,000.
I got to take 200 times 4,000 squared. That's a lot of zeros, right?
Uh-oh, time to do that.
I could write it in scientific notation. If I don't write it in scientific notation, basically I end up with 200 times 4,000 times 4,000. So calculators, what does that come out to be?
32,000,000,000,000.
Okay, so without looking at the calculator screen, how many zeros should there be? Because I got 3 here, and then 3 more, and then 2 more. So I should have 8 zeros, right? A 32 with 8 zeros. So K is a 32 with 8 zeros. So I could even write it like this if I wanted. Or you can actually write out a 32 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now, I realize that that's not proper scientific notation. Proper scientific notation, you would put a decimal point here and then put a 9 here. But I don't care about proper...
Broadcast, report to the stadium outside, please. Broadcast to the stadium.
I don't care about writing this in scientific notation properly because this is not my answer, right? This is just an intermediate number. Okay, so if that's my K value, now I have this formula. I have force equals 32 times 10 to the 8th, and if you would just rather write a 32 with 8 zeros, go right ahead, divided by d squared. Okay? And now I have new numbers to plug in. What am I supposed to find?
You're supposed to find,
How much this astronaut weighs when he's out here, right?
Yes.
So I'm looking for force, the force on his body when he's how far from the center of the earth? How far is he from the center of the earth now that he's out here?
7,700.
7,750. So a picture is kind of important in this problem, so you can reference that picture when you look back in your notes, hopefully. All right, so force is equal to 32 times 10 to the 8th, or if you just want to put 8 zeros, that's fine, divided by 7750 squared. You agree with that? Okay, does anybody know how to type a scientific number into the calculator without having to type in the times 10 to the 8th power?
Yep.
Yeah.
Use that E key. So physics students, you should know that. Right here, there is a double E on your calculator. Okay, so if you hit 32 and the blue key and then the comma key, the only thing you would have to type in after that is the exponent. Okay, so you type in 32, second comma, to tell the calculator you're going to go to scientific notation, and then all you're going to do is type in the 8. Okay, so on your screen, it would look like this. 32, and then this little E will pop up when you hit second comma, 8 divided by 7750 squared. Now, can you still type in a 32 with 8 zeros and then divide by 7750 squared? Absolutely. Okay, I'm just showing you the shortcut. You can it'll look like this on your screen if you type it in using the calculator's scientific notation option. Okay, so if you type that in, what are we going to get, guys?
Big boy.
Yeah, it's going to be a big answer. Okay, and it says round to 1 decimal place. So if I round to 1 decimal place, what will I get? 53.3?
Yep.
Okay, so he weighs 53.3 pounds when he's in that far away from the center of the earth. Okay? He was 200 pounds on the surface of the earth. So as he gets farther and farther away. Okay? Everybody okay with that?
Yeah.
All right, so one more example to do.
That was close.
I think we all start hard stop for a minute.
Okay, number 7. Remember, I'm recording, guys.
Said a little prayer.
Okay, so number 7, the distance that an object falls from rest when air resistance is negligible varies directly as the square of time. Okay, so distance is my keyword there, and varies how? Directly as the square of time. So distance, I always put equals k. If it's directly, I multiply. Inversely, I divide, right? So the square of time. So there's my formula. Distance varies directly as the square of time. Everybody with me? Okay, so tell me what numbers I need to fill in next.
The distance of 349 feet.
Okay, 349 feet is my distance. How long does that take?
6 seconds.
6 seconds. So I'm going to replace t with a 6. Okay, how do I solve this thing for k?
Divided by
349 divided by 36. So type that in your calculator and tell me what k, well, let's just leave it. And we did test this yesterday in 6th hour. They do not round an intermediate answer if you can avoid it, okay? See how it says you can round to the nearest integer? You don't only want to do that with your final answer, not your intermediate answer. We tried it in 7th hour yesterday, and we rounded this to the nearest integer, and we got it wrong, okay? Because it makes your answer come off 1 unit off of what it would actually be. Okay, so let's rewrite this formula, replacing k. Let's just leave k as 349 over 36. 349 over 36 times time squared. And what do I know? What can I plug in now? It says find how far, so that means the distance, how far will it have fallen at the end of 8 seconds? So replace time with 8 seconds. So I'm going to have 349 over 36 times 8 squared. So type that in your calculator for me. If you do, it's going to look like this: 349 divided by 36 times 8 squared. Okay, your calculator knows to work. It's going to do the exponent. It's going to make this a 64. Then it's going to come back here and go from left to right. So we'll be fine as far as how that's going to work out without a parentheses.
I got 600.
So to the nearest integer is 620. That means no decimals.
Yes.
Everybody good with that? All right, so that's all there is to it. You got the rest of the time to work.